today we are going to start with the decimal representation of rational numbers. So rational numbers, we have two definitions. One is a numbers can be written in the form of p by q. P and q are integers. Q is not equal to 0 and co-prime. They are called as rational numbers. So based on the decimal expansion, we have another definition for rational number, that is a number whose decimal expansion is terminating. Okay, terminating means having n, or non-terminating repeating is called as rational number. For example, 3.1426 is terminator, or 0.535353. So this is non-terminating but recurring. 5353 is recurring, repeating. Therefore, this is comes under rational number. Okay. The next one is irrational number. If the number cannot be written in the form of p by q, p and q are integers and q is not equal to 0, that is irrational number. For example, root 2, root 3, root 5, root 7, these are all irrational number. So based on the decimal expansion, a number whose decimal expansion is non-terminating, non-recurring. Non-terminating means there is no end. The same way it will not repeat. This type of numbers called as irrational number. For example, going in a pattern. Okay, 150, 1500, 15000, 1540. It's going in a pattern. Okay, this is irrational number. Root 2, root 3, pi value. Okay, real numbers dividing into rational numbers and irrational numbers. Again, rational number means if it's a terminating decimal or non-terminating recurring is rational number. If it's non-terminating, non-recurring is called as irrational number. Right, so next, okay, I'll be just teaching how to locate root 2 on the number line. Okay, for representing irrational numbers, root 2, root 3, root 5 means the first step, right? So we have to identify how to get a root 2. So based on Pythagoras property. Okay, so for that, first, right, how to get root 2, we have to identify this. Suppose if we are just taking, okay, number line, we can just take any number line. So if we are just drawing a number line, right? So root 2 we have to get, right? For locating root 2 first, right? So in the number line, I'm just taking 1 unit. Okay, 1 unit. And then you have to take 90-degree perpendicular line. Okay, so I just draw the 90-degree perpendicular line, that also 1 unit. So this side 1 unit, this side 1 unit. Right, it's forming 90-degree here. Right, I can apply the Pythagoras property. If you know two sides in a triangle, right angle triangle, I can just easily identify third side based on Pythagoras property. Here OB square is equal to OA square plus OB square. So OB square we have to find out. Okay, OB square means here OA we have taken 1 unit, AB have taken as 1 unit. Okay, 1 square plus 1 square. Okay, you will be getting 2. OB square is equal to 2. Therefore, OB is equal to root 2. So we are getting root 2. Actually, from here to here, so we will be getting root 2. The same concept, we are just going to do it in the number line. First, you just draw the line and just mark O. Okay, you can just mark O. This I'm just marking as O. Then from O, just take 1 unit. 1 unit, either it can be 1 centimeter or 2 centimeter. So I'm just taking from here to here. This is 1 centimeter. So from here to here, I'm just marking 1 centimeter. That is 1 unit. Here I'm just taking 1 unit. Then from this, I'm just marking this is O, this is A. From A, keep your protractor and mark 90-degree. Okay, I'll just mark 90-degree. So this is 1 unit means, so from here also I have to take 1 unit. So 1 unit I can just draw 90-degree. This also should be 1 unit. Okay, 1 unit. Now we can just mark this point as B. Okay, I'm just marking this as B. Now I can join OB. Okay, now if I join O and B, okay, this is my root 2. Okay, this is my root 2. Why? Because 1 square plus 1 square, you will be getting 2. If you are taking square root, you will be getting OB is equal to root 2. Actually, I have to mark root 2 on the number line. Actually, this is our number line. Right? So what you have to do means just take your compass, keep the pointer. Okay, keep the pointer in O, open your compass up to OB. Just measure up to OB, keep the pointer in O, and from this you have to draw an arc. Okay, just draw the arc by the help of your compass. Okay, where this arc is intersecting on the number line, so this is called as root 2. Okay, this is our root 2. Once again, I'm just repeating. Just first you just take 1 unit in the number line, draw the 90° and mark one unit, join OA, take your compass and keep the pointer in O, measure this OB length and keep the pointer in O and draw an arc. Where the arc is intersecting on the number line, so this is our root 2. So I'll be just showing the steps of construction. Step 1, on the number line, we measure OA is equal to 1 unit. 1 units, that is up to your choice. Either you can take 1 centimeter or 2 centimeter as 1 unit. And draw perpendicular on OA through A, 90°. Step 2, on the perpendicular line, we mark B such that AB is equal to 1 unit. And then join to the origin, join OB. So clearly now OB is equal to root 2. Okay, OB is equal to root 2 units. Step 3, with O as a center, OB as a radius, with the help of compass, we draw an arc which intersect the number line at P. So if you want to just, we can just name this as P. So it's clearly now OP is equal to root 2 unit, root 2 unit. Hence, P represent the irrational number root 2. Okay, the P represent irrational number root 2. So now next one. So if you want to draw the root 3, so what do you do? We just got, this is our root 2. Okay, this is root 2. We just constructed 1 unit, and this is our root 2. For getting root 3, again from this point C, you have to take 90° perpendicular line. Again, you take 1 unit and join. Okay, this is a center. Okay, center means so join this O and D. So this is our root 3. For getting root 4, again take 90° line. Okay, take 1 unit and join O and E, root 4. Next, the same 1 unit. Okay, 90° line. So join O and F, root 5, root 6, root 7, root 8. Okay, until you will be getting here up to root 17. Okay, so this is like a square root spiral construction. In case they are asking the question, okay, exam point of view, construct root 2 means we will do it. Root 3, root 5. This is one of the method to construct, okay, irrational numbers on the number line. Okay, one by one, step by step, you can just construct. Other way also is there. For example, if you want to construct root 5 on the number line means you can just apply the Pythagoras property. How to get root 5? So root 5, what are the units I can just take? If I take root 5 means I can just take here 2 units. So 2 units, and here if I take 1 unit, okay, 1 unit. So if I join here, so 2 units, 1 unit. So 2 square, okay, 2 square plus 1 square, correct? 2 square I'm just getting as 4. 1 square is 1. So 4 plus 1 is I'm just getting as 5. Okay, actually if I just take this, this is A, B, C, apply the Pythagoras theorem. AC square, right? AC square should be equal to 2 square plus 1 square. So AC square is equal to 4 plus 1. Now AC alone, I have to take the square root. Okay, AC alone, if you are writing, AC is equal to square root of 5. So I no need to go with root 2, root 3, root 5. Okay, root 3, root 4, root 5. So we can directly also we can just draw the Okay, root 5 on the number line. Here 2 units, 1 unit. Okay, just try the possibility whether you can be able to draw it directly. So root 3 construction is given here. First, you have to construct root 2. Okay, this is the construction for root 2. Correct? First, we are just taking 1 unit, 1 unit. So join, we are getting root 2. For getting root 3 means what? So root 3, how will we get in the applying the Pythagoras theorem, right? So if we are just taking AC square means, so 1 unit should be root 2 square plus 1 square. Root 2 square is 2 plus 1. So AC square is equal to 2 plus 1. So AC square is equal to 3. Now AC is equal to root 3. That means 1 unit should be root 2 unit, another one should be 1 unit. So that we will be getting root 3. For constructing root 3, first you have to construct root 2, then 90 degree, 1 units, then join A and D. Okay. Now this is our root 3. So square root spiral, we are just using in different pattern, right? So you can just see here, square root spiral. So we are going to give proof by contradiction. Proof by contradiction. Contradiction, which means first I am just going to assume root 2 is rational. Okay, if it's rational means we can write it as in the form of P by Q. P and Q are integers and Q is not equal to 0. Then I will do some steps. So at the end, right, I will be getting contradiction. Okay, my assumption it will be wrong. So therefore, root 2 is irrational. Okay, proof by contradiction. Okay, first I am going to assume. Okay, first I am just going to assume. First I am just writing proof. So proof. Okay, let us assume first. Okay, let us assume. So root 2 is rational. Okay, root 2 is rational. Okay, if it's a rational, I can just write root 2 can be written as P by Q format. So root 2, I can just write it as P by Q. Okay, P and Q are integers. The condition is Q is not equal to 0. Next, P and Q are integers. P and Q are integers co-prime. Okay, so co-prime means that should have only one as a common factor. P and Q are co-prime, which means P and Q should have only one as a common factor. Right? Now next step, what you will do means, so I'm just going to square on both the sides. Okay, if I square on both the sides, okay, root 2, if I take the whole square, it will become, you will be getting only 2. Okay, 2 is equal to P square by Q square. These are the steps you have to understand, you have to do it. I'm just taking square on both the sides, right? So if I take square root and square will get cancelled, will be getting only 2 P square by Q square. Now just interchange. I'm just going to bring this 2 to this side, Q square to this side. What will I get? So Q square, it will come here, right? Q square is equal to P square by 2. P square by 2. I'm just taking this as first equation. Okay, here 2 divides P square. Okay, 2 divides P square. Therefore, I can say 2 divides P also. Okay, this is actually is given as a theorem in grade 10th. Okay, since 2 divides P square, here I'm just writing since 2 divides P square, okay, then 2 divides P also. 2 divides P also. Okay, for example, if 2 divides, okay, any numbers, so 2 divides P square, the square number, 2 divides P also. This is one of the theorem is given in 10th. You can, at present, you can just take this result as it is. If 2 divides P, we can write 2 is the multiples of P. I can write 2 divides P means, so 2 can be the multiples of P. So I am just writing P is equal to, okay, 2 is the multiples of P. So 2 into K I am taking. 2 divides p means p is the multiples of 2. So p can be written as p is equal to 2k. So k is an any integers. Okay, k is an any integers. So it can be 1, 2, 3, 4, right? So p it can be in any integers. 2 divides p means, so 2 is the multiples of p. So p is equal to 2k I can write. Now in the place of p, I am going to substitute 2k. Okay, in the place of p, I am going to substitute 2k. So from 1, okay, so from 1, okay, so q square is equal to, in the place of p, I have to substitute 2k, right? So 2k the whole square just divided by 2. Just simplify it. So q square is equal to 2 square is 4. 4. So k square is k square. Just divided by 2. Now I can just divide 1 2s are 2, 2 2s are 4. Now I am just getting as 2k square. Okay. So now next. So now just what I'm getting. So q square is equal to 2k square I'm getting. Now I'm just taking 2 to this side. So I'll be getting q square divided by 2 is equal to k square. That means here 2 divides q square. Therefore 2 divides q also. Okay, since 2 divides q square. Okay, 2 divides q square. Then 2 divides yeah, q also. That means from this I can say P and Q are having 2 as a common factor. Okay, P and Q are have 2 as a common factor. So from this I can say P and Q, P and Q, P and Q have 2 as a common factor. 2 as common factor. Okay, actually we have taken P and Q are co-prime. Co-prime means that should have only 1 as a common factor. Here we have proven that 2 also is a common factor. This gives contradiction. Okay, this gives contradiction. We can just say this gives contradiction. Okay, therefore my assumption is wrong. Therefore our assumption is wrong. Assumption is wrong. What is our assumption? I have taken root 2 is rational. I have taken. So now my assumption is wrong. Therefore we can just say root 2 is irrational. Root 2 is irrational. Okay, so once again I'll just repeat. We have to prove root 2 is irrational. For that I am just assuming root 2 is rational. If it's rational, we can write in the form of p by q. Q is not equal to 0. P and q are integers and co-prime. Co-prime means that should have only 1 as a common factor. We have proven p and q are having 2 as a common factor. 1 also common factor and 2 also common factor. It's having more than 1 common factor. Therefore, this gives contradiction. Our assumption is wrong. So, root 2 is irrational. This is called as proof by contradiction. So, if you want to prove root 3 means in the place of 2, you just take it as 3. Okay, I'll just explain quickly, right? So, in the place of, you just take 3, root 3, right? So, root 3 here, what will come? If you are squaring on both the sides, it will become what? 3 square is, sorry, root 3 square is 3. Now, here you will be getting 3. So, here what you can write? If 3 divides p square, therefore 3 divides p also. So you'll be getting p is equal to 3k. Okay, now here it will be coming as 3. Now, here if you're just squaring, what will come? This will become 9. So 9 by, this is 3. Yeah, here we'll be getting 3k. Now again, this will be 3. And here this will be 3. So 3 divides q square. Therefore 3 divides q also. Now p and q have 3 as a common factor, more than 1 common factor. This gives contradiction. Okay, if it's 5 means wherever 2 is coming, replace with 5. P and q, it will be having 5 as a common factor. Our assumption is wrong. Next, converting rational decimal into p by q form. So we have 3 cases, right? First one is terminating decimal. Terminating decimal means that's having end. A terminating decimal is a decimal that has a finite number of digits after the decimal point. First case is terminating decimal. That means, right, if it's given 0.25, if you want to write this as P by Q format, right? So 25 by 100, okay, it's 1 by 4. Okay, that means it's having finite number of digits. Okay, finite number of digits means we can just able to count. After the decimal point we have two digits alone. Finite number of digits. This is terminating decimal. Second one is pure repeating decimal. Okay, pure repeating decimal means after the decimal point, immediately after the decimal point, okay, the digit will repeat. It's given the sequence of digit begins repeating immediately after the decimal point. Okay, this is the decimal point. Immediately after the decimal point, the 3 is repeating. 3, 3, 3, 3, 3. This is called as pure repeating decimal. Another one is, so general repeating decimal. So general repeating decimal means after the decimal point, immediately will not repeat. Okay, here you can just see. After the decimal point, one number is coming. After the number, the 3 is repeating. A general repeating decimal has some non-repeating digit just after the decimal point. That means after the decimal point, we will be having one non-repeating digits followed by repeating the block. This type of numbers are called as general repeating decimal. Okay, this is for your understanding, right? First one is terminating decimal, pure repeating decimal. Third case is general repeating decimal. In case they are asking one mark purpose, you must know. Next one is cyclic number. Cyclic number means a cyclic number is a decimal in which one or more digits repeat infinitely in the same order. Cyclic number means the decimal, okay, the decimal in which one or more digits, it will repeat. Okay, digit will repeat infinitely in the same order. For example, if you are just dividing 1 by 7, so we get 0.142857. Again, this 142857, it's repeating. Okay, again, it's repeating. So these type of numbers are called as cyclic number. And then one more amazing things is to be noted. Here 142857 into 1, we are getting the same. Into 2, we are getting this number. 3, 4, 5, 6. If you notice everywhere, okay, the same digits are repeating in a different order. Okay, here 1 is here, 1 is here. 4 is here, 2 is here, 8 is here, 5 is here, 7 is here. We are having 6 digits, but in a different order. Okay, this beautiful internal structure is the hallmark of rational number of 1 by 7. The same digits simply shift in the cyclic circle. Okay, cyclic number means, right, so the digit will repeat infinitely in the same order. So one important note, if a rational numbers P by Q is in this simplest form and the denominator Q can be written as Q, the denominator Q can be written as 2 power m into 5 power n, then the decimal expansion is terminating. Okay, if the P by Q format is given and if it's a simplest form, the Q is written in the form of 2 power m into 5 power n, the decimal expansion is terminating. For example, 7 by 20. We have to check 7 by 20 is terminating or non-terminating repeating. We no need to divide and check. Instead of dividing and check, so check the denominator 20. 20 can be written as in the form of 2 square into 5. So it's having 2 power m into 5 power n. Therefore, we can say this is having terminating decimal. Okay, if normally if you are just dividing 7 by 20 means you are getting 0.35 decimal expansion terminating. So in case if the denominator, if you have only 5 power n, only 5 power is there is no 2 power. In that case also it will be terminating. Why? Because 2 power 0 is equal to 1. 5 power n is there means we can write it as 5 power n into 2 power 0. For example, 3 by 25. We have to check 3 by 25 is terminating or non-terminating repeating. What do you have to check? We no need to divide 3 by 25. Just take the denominator and find the prime factor. 25 prime factor is 5 square. Only 5 square is there. So this can be written as 2 power 0 into 5 square. So it's in the form of 2 power m into 5 power n. Therefore, this is terminating. Exercise 3.5, question number 1. Without performing long division. Okay, we should not divide. Without performing long division, determine which of the following rational numbers will have the terminating decimal and which will be repeating. 7 by 20, 4 by 10 and 13 by 250. Then check your answers by explicitly performing the long division and expressing these rational numbers as decimal. Right, so what I have to do means without doing the long division means, so this is in the form of p by q. So I have to check the prime factorization of q. Okay, so first I am just finding the prime factorization of q first. Here prime factorization of 20. Okay, 2 square. Okay, prime factorization of 20 means I can just write it as 20 can be written as 2 square 4 into 5. Correct? 2 square is 4. 4 5s are 20. Since the denominator has only prime factor 2 and 5, the decimal expansion is terminating as we learn the theorem. We can write in the form of 2 power m into 5 power n. So it's a terminating. Now we have to divide and check. Okay. Now we have to divide and check. I will be just showing the division here. If you are dividing 7 by 20, 7 is less than 20, right? So we cannot divide. So take 0 and add 1 0 here. Now it's 70. Right? In 70, how many times 20? 3 20s are 60. Balance 10. Okay. Okay, balance, yeah, 10. Hmm. Now again, so we have to take 1 0. In 0, how many times? 20 is 100. So remainder is coming as 0. If you are dividing 7 by 20, the answer is coming as 0.35. It's having terminating decimal. Okay, the number is terminating decimal. This is we have done the long division performance for checking the answer. Now, second question, we have to find the prime factor of 15. Okay, prime factor of 15, you can write it as, so this is 3 into 5. Okay, 3 5s are 50. Since the denominator has the prime factor, okay, other than 2 and 3. So other than 2 and 5. 5 is there, but 2 is missing. Okay, therefore the decimal expansion is non-terminating repeating. Second case, non-terminating repeating. We can just divide and check. I'll be just showing the division. Okay, if you are dividing 4 by 15, okay, do the divisions. We are getting as 0.26666. Okay, the decimal expansion is repeating decimal. Okay, repeating decimal. So 6 is repeating. 666 is repeating. Okay, now this is second question. For the third question, 13 by 250, right? So I have to find the prime factorization of 250. Okay, prime factorization of 250. So prime factor of 250. So 250 prime factorization. So 2 into 5 cube. Okay, 2 into 5 cube. Okay, 2 into 5 cube, we will be getting 250. Since the denominator has only the prime factor 2 and 5, the decimal expansion is terminating. Okay, now again you have to check by the long division. If you are just dividing 13 by 250, so do the normal division, so you'll be getting 0.052. The terminal now the decimal expansion is terminating decimal. It's having an end. Okay, this question is based on this property. Okay, if the denominator can be written as in the form of 2 power m into 5 power n, that is the terminating. Otherwise, it's non-terminating repeating. Hope you can understand this. Question number 2. Perform the long division for 1 by 13. Identify the repeating block of digit. Does it show the cyclic properties if you evaluate 2 by 13? Next, now you compute 3 by 13, 4 by 13, etc. So what do you notice? So first you have to do the long division for 1 by 13. Okay, I'll be just showing the 1 by 13 long division. Right. So if you are just dividing 1 by 13, okay, 1 is less than 13, right? Directly we cannot divide. Just take decimal point. Now it will become 10. Again, 10 is not divisible by 13, right? Take 1 0, it will be 100. Here you have to take 0. Now in 100, how many times 13? 7 times 7, 13, so 91. So balance 9. Okay, so bring down. Okay, the 0. Again, in 90, how many times? So we have 6 times. Next 7, 2, 3. Just do the process. Okay, after reaching here, right? So here we just started with 1. Again, here we just started with 1. 49, 40 minus 39 is 1. Okay, 49 minus 39 is 1. Again, from here is going to repeat. Started with 1, again here 1 is coming, so it's going to be repeat. That means 076923 is going to be repeating. From this is going to repeat. Now based on this, we have to find out 2 by 3, 2 by 13, 3 by 13 and 4 by 13. Okay. Now we found out 1 by 13 is equal to 0.076923, right? So this is repeating, okay, which is repeating, this everything is repeating. So repeating blocks are 076923. So repeating blocks are 6 digits are repeating. We know that 1 by 13 is equal to 0.076923 repeating blocks. For getting, if you want to find out 2 by 13. So 2 by 13 is nothing but 2 into 1 by 13. Okay. So 2 into 1 by 13. With the 1 by 13, we have to just multiply with 2. Just multiply with 2. Here we are just multiplying with 2. What is coming? 3 2s are 6. 2 2s are 4. 9 2s are 18. 1 is carryover. Right? So the same way, if you are just multiplying, so you will be getting this. Again, if you are multiplying 3 with this, you will be getting 3 by 13. If you multiply by 4, you will be getting 4 by 13. 5 5 by 13. 6, right? 6 by 13 you will be getting. Okay, everywhere 6 digits are repeating. Okay, 6 digits are repeating. Now, so what do you notice? What you are noticing from this? Okay, my observation is all fraction 1 by 13, 2 by 13, 3 by 13 have repeating decimal with a period of 6 digits. Okay, for every word, the repeating block is 6 digits. The period of repeating digit is going to be 6. Okay, we'll make it very simple. Question number 3. Classify the following numbers as rational or irrational. So the questions are given. We have to identify whether the given number is rational or irrational. Okay, by seeing the square root, directly we cannot say a square root is having, therefore it's irrational. It's not like that. Inside the square root, if you're having the perfect square number, right, it's a rational number. For example, root 81 is a perfect square number. Okay, the root 81 value is 9. 9 is the rational, not irrational. Root 12, okay, root 12, okay, 12 is not a perfect square number. So this is the irrational number. Okay, and 0.3333 is non-terminating but is repeating. Therefore, this is comes under rational number. And here also this one 0.1234, right? This also non-terminating. Non-terminating means they will be keeping dot dot dot, no end, but it's repeating. 1 2 3 4 5 is repeating. Okay, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5 is repeating. Therefore, this is rational. Fifth one, 1.0100, right? It's not repeating, but it's following the pattern. 10, 20, 30, 40, it's forming a pattern. Non-terminating, non-repeating. Therefore, this is irrational. Sixth one, it's having an end. Okay, terminating one. So, terminating means it's a rational number. Okay, after this they are asking find the explicit fraction. Okay, explicit fraction means you have to write rational number in the form of p by q. Okay, decimal is given, you have to write the decimal as p by q format. P by q format, right? The first one, okay, root 81. Root 81, the square root of root 81 is 9. Okay, since 9 is the rational number, so root 81 is the rational number. Okay, now the second one, okay, root 12. Root 12 can be split into 3 into 4. Okay, 4 is a perfect square number, you can take outside. 2, okay, 2 root 3. So we know that root 3 is irrational. As root 3 is irrational, 2 root 3 is irrational. Therefore, 12 is irrational. Next, third question, 0.333 is non-terminating but repeating. Okay, non-terminating is repeating. Therefore, this is rational. Okay, if it's a rational, we have to write it in the form of explicit fraction. Okay, p by q format we have to write. Okay, I'll just explain how to write it in p by q format. One question if you are understanding, so balance everything is going to be the same. Okay, first step, right? They have given, okay, this is non-terminating repeating. Okay, non-terminating repeating, and the repeating digit is coming immediately after the decimal point. Okay, the digit is repeating immediately after the decimal point, so the name is called as pure repeating decimal. Okay, if it's not repeating immediately after the decimal, that is called as general repeating decimal. Okay, this is repeating immediately after the decimal point, therefore this is pure repeating decimal, right? So now first step for third one, first step, let x is equal to, okay, let x is equal to 0.333. Okay, dot 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 dot. This is I'm just taking as equation number 1. First point. Second, just see how many digits are repeating. Here only one digit is repeating, only 3 is repeating, 3333. As only one digit is repeating, so I have to multiply by 10, that is 10. If it 2 digits repeating, I have to multiply by 20, 100. If 3 digits are repeating, I have to multiply by 30, 1000. As here only one digit is repeating, so I have to multiply by 10 on both the sides. Okay, I'm just multiplying 10 on both the sides. So 10 into x is equal to 10 into 0.333, etc. Now just multiply it. So 10 into x is I will be getting 10x is equal to 10. If you are multiplying, the decimal will move towards right side one place, you will be getting 3.33. Here you have to note one thing, right? After the decimal point, we should have equal number of decimal part. Just see here in equation number 1, after the decimal point, I have 3 digits. Okay, here also I have to make it as 3 digits. So I can just take one more 3, etc. Why? Because 3 is repeating. How many times if you want, you can just extend. There is no problem. So make sure that after the decimal point, we should have equal number of decimal part. 3 decimal part, here also 3 decimal part. Now we can take it as this is equation number 2. Now third step, we have to subtract. Equation number 2 minus 1. I have to subtract 2 minus 1. Equation number 2 minus 1. Just subtract. So 10x minus x is equal to 3.333 minus 0.333 . So 10x minus x will be getting 9x. 9x is equal to now 3.333 minus 0.33. After the decimal point here 333, it will become 0. 3 minus 0 is 3. We are getting as 3. If you are subtracting this minus this, you will be getting 3. Now x is equal to 3 divided by 9. So 3 by 9 is 1 by 3. So x is equal to 1 by 3, right? Therefore, it's written in the form of p by q. Okay, that is called as explicit fraction format. Okay, from this I can just write x. X is equal to 1 by 3. Once again, I'll just repeat. First, you just take the given value as x. Then just see how many digits are repeating. As many zeros you have to multiply. Here only one digit is repeating, so multiply by 10. Then take it as second equation. And one more thing, after the decimal point, we should have equal number of decimal part. 2 digit mean 2 digit, 3 digit mean 3 digit we should have. Then subtract 2 minus 1, simplify, will be getting the p by q format. Now fourth question, 0.12345, 12345, 12345, right? So here is nothing but 0.12345 is repeating. Okay, this is repeating. 1, 2, 3, 4, 5 is repeating. So this is non-terminating, repeating. Therefore, this is rational number. If it's a rational number, you have to write in the form of p by q. Explicit fraction format you have to write. Okay, the same like, okay, third question. So first step you have to take, let x is equal to, first you just take let x is equal to 0.12345. Okay, 1, 2, 3, 4, 5. Okay, dot. This is my first equation. As here, how many digits repeating? 1, 2, 3, 4, 5 digits are repeating. Okay, as 5 digits are repeating, I have to multiply with 5 0. I'm just multiplying with 5 0. 1, 2, 3, 4, 5 0. That means 1 lakh. I'm just multiplying with 1 lakh into x is equal to, just multiply with 5 0. Okay, 1, 2, 3, 4, 5 0 in both the sides into 0.12345, 1, 2, 3, 4, 5, dot. Now just multiply it. Okay, 1 lakh into x is, will be getting 1 lakh x, 1, 2, 3, 4, 5 into x. Here, if you are just multiplying, you have to move the decimal point towards right side 5 place. From here to, it will move 5 places. 1, 2, 3, 4, 5, point 1, 2, 3, 4, 5. Okay, as I said, after the decimal point, we should have equal number of decimal part. Here I have 5 decimal part. In the equation number, after the decimal point, I have 10 decimal part. So I can just take one more term, repeating term. So I can just take it as again, once again, 1, 2, 3, 4, 5. So dot. Dot means how many times if you want, you can just exchange. Okay, extend. Now the second one, this we can just take it as second equation. Now just subtract 2 minus 1. Equation number 2 minus 1. Okay. I'm just directly doing it. Okay. 1 lakh x minus x. 1 lakh x minus x will be getting 99,999. X is equal to. Okay. Now this is 12,345 minus 0 will be getting the same, right? So 12,345 after the decimal point is same, right? So if you are just subtracting, this will become 0. As this is a pure repeating decimal, after the decimal point, it will become 0. Now next step, you just take this, okay, this number to the next side. So x is equal to 1, 2, 3, 4, 5 just divided by, okay, 1, 2, 3, 4, 5 nines. Now we can just simplify it. Okay, both it will be divisible by 3 table, right? So I can just divide with 3. Okay, 3 3s are 9, 3, 3, 3, 3. Here numerator 4 3s are 12, right? Next 1 3s are 3. Again 1 3s are 3. Balance 1, it will become 15. 5 3s are 15. So now therefore x is equal to 4115 just divided by 3, 3, 3, 3, 3. So this is P by Q format, explicit fraction format. Now question number 5. Okay, question number 5, 1.01, okay, 00, 000, okay, then 5 zeros. It's repeating on pattern. Okay, so not repeating decimal, but it's going in the pattern. Non-terminating, non-repeating. Therefore, this is irrational number. Sixth one, it's having terminating. So terminating means this is rational number. Okay, terminating means this is a rational number actually. Okay, this is rational. If it's a rational, again you have to write it in the form of P by Q. How to write as a P by Q? How many decimal part? Just check how many decimal part, as many zeros you have to divide. Okay, after the decimal point, we have 21 decimal part. From here to here, we have 21 decimal part. Just divided by 21 zeros. So you'll be getting the same answer. P by Q format. Question number 4. The number 0.9 bar. Bar means it's repeating. 9 is repeating. Instead of writing 9999, we'll be placing as bar. Okay, over 9. That means 9 is repeating. It's a rational number. Using algebra, let x is equal to 0.9 bar, multiply by 10 and subtract. Explain why 0.9 bar is exactly equal to 1. Okay, what we have done previous question, the same concept. Okay, so first you can just take let x is equal to, okay, let x is equal to 0.9 bar. We can take the 0.9 dot dot dot. This is our first equation. As only one digit is repeating, so I have to multiply by 10 on both the sides. So 10x is equal to 10 into 0.99. Just multiply it if you will be multiplying it. So this is 10 into x is 10x is equal to. So if you multiply, it will become 9.9. Check that after the decimal point, we should have two decimal point. As here, equation number 1, two decimal point, you can just take one more zero also. Okay, dot dot dot. I can take this is my second equation. Now 2 minus 1, equation number 2 minus equation number 1. Okay, just subtract. So we're just subtracting 10x minus x. So we'll be getting here 10x minus x is equal to 9.99 dot 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 minus 0.99 dot dot. So 10x minus x is will be getting 9x is equal to 9.99 minus 0.99, you will be getting 9. Now x is equal to 9 divided by 9. So 9 by 9 is equal to 1. So x is equal to 1 we are getting. So the given is 0.99. If you are just rounding off, you will be getting 1. The same wise, if you are writing in P by Q format, you are getting the answer as 1. Now we'll be just moving on to the question number 5. Question number 5. So we have seen that the repeating block 1 by 7 is a cyclic number. So try to find more numbers n whose reciprocal 1 by n produce the decimal with repeating blocks that are cyclic. Okay, cyclic means we already just learned here. Okay, this is cyclic. Cyclic means, okay, it's the decimal in which one or more digits repeat indefinitely in same order. 1 by 7. Okay, 1 by 7 value is 0.142857. Again, 142857 is repeating. So repeating in a cycle. That is called as cyclic number. Okay. The same thing here they are asking us. Okay. So we have seen that 1 by 7 answer is cyclic. So we have to go with some other cyclic number now. So we know that 1 by 7, the answer is 0.142857, right? It's repeating. Okay, this is repeating. It has repeating block whose digits appear in cyclic order. The same 6 digit will repeat. Okay, next again 6 digit. Next, okay. So it will repeat again and again. Similarly, we can find the value n such that 1 by n gives cyclic repeating decimal. For example, 1 by 13. If you are dividing 1 by 13, so we'll be getting the answer as 0.076923. Okay. So here also 6 digits is going to be repeating. It's forming cyclic. Next 1 by 17. Okay, 1 by 17 also is going to give the cyclic number. Okay, if you are just dividing 1 by 17, right? So repeating decimal. Okay, the cyclic is started from after 16 digits. Okay, 19. 1 by 19 means starting from after 18 digits. After 18 digits, we'll be having the repetition. 1 by 23 is starting after 22 digits is repeating. Okay, right? So 1 by 13. Okay, except this case, except 1 by 13, just see, right? 1 by 7 means, okay, the repeating blocks are 6 digits. 1, 2, 3, 4, 5, 6 digits. 17 means 16 digits. 1 by 13, 1 by 23, 1 by 7. Okay, in these three cases, right? So how we can find out the repeating block means, so here you can just see, if n is a prime number, the length of repeating cycle is n minus 1. Okay, for few numbers, 1 by 7, 1 by 13, 1 by 23, 1 by 23. Okay, these type of numbers are called as full repton prime. Full repton prime means, right, if n is prime means n minus 1. After n minus 1, it will be repeating. 7 means 7 minus 1, 6. After 6 digit, we will be getting the repeating block. Right, so 1 by 7, 1 by 17. Okay, 17 minus 1 is 16. After 16 digit, we will be getting a repeating block. 1 by 23. So 23 minus 1 is after 22. We will be getting a repeating block. Okay. So this is one of the, right, so important note. You can just make a note of it. And one more thing, they are telling that everything is following the cyclic number. Cyclic number means the same number will repeat again and again, infinite number of times. Now try to find more number, that is n, whose reciprocal is 1 by n. If you are just taking the number is 13 means reciprocal of 13 is 1 by 13, 1 by 17, 1 by 19, 1 by 23. We have taken all the numbers. Okay. Their reciprocal produce cyclic repeating decimal. So wherever the star mark is given, so this is like higher order questions, right? So we have to think a lot and answer it. Up to this, we are just completing exercise 3.5 is completed.